All right, so this is day 2 of our Cornerstone unit looking to factor. Always, always, always find the GCF, find the greatest common factor first. What is the term that goes into all of the terms? Not everything always has a GCF, but if there is one, take it out first. It's going to make the rest of the factoring much simpler. And we're looking at 4 methods here, and then a 5th one that actually isn't a method. The first one, when we have something like this, 2 terms separated by a minus sign, and they are both perfect squares. The method is difference of squares. And the way we factor it is to look at the square roots. What is the square root of 4x squared? 2x. So 2x is going to go first. What's the square root of 49? 7. So 2x 7 for both of them. Then what's the symbol that goes between the 2x and the 7? There's a minus and a plus. So if I were to multiply all of this stuff back out, it would give us back to the original problem, which isn't the form that we want it in right now. We want to keep it in this factored form because these are linear now. They're smaller and easier to work with. So there's our first kind of factoring. It is difference of squares. Letter B. This time we have a quadratic, x squared. It's a trinomial because there are 3 terms, and the number in front of x squared, the leading coefficient is just a 1. Do you remember what this method is called? Number pairs. Number pairs. Pair means 2. What is the pair of numbers, or what are the 2 numbers that multiply to negative 45, and those same 2 numbers add up to negative 4? So numbers that multiply to this and add to this. All right, so 9 times 5 is 45. They're different by 4. In order to get a negative 45, one of the numbers is negative. So now if you multiply these, there's negative 45 like we need. And if you add those together, is that negative 4? Yep. So it factors then as x minus 9, x plus 5. We can go directly to the answer. There it is factored. Number pairs when you have a trinomial, 1, 2, 3 terms, quadratic, x squared, and the leading term is a 1. Now letter C has 4 terms, so it's a little bit different. It's not a quadratic. There's 4 terms. What is this one called? Grouping. When there's 4 terms, we try grouping. There is no big GCF that goes into all 4 of them, but group the first 2 together, group the last 2 together. So what is the GCF for these first 2 terms? What goes into both of those? X squared. And if you take an x squared out of both of them, then what would go inside of parentheses? 3x plus 7. So if you distributed, that'd get you back to what you originally had. So this is the same thing as this. And then for the back half, what's the GCF between 18x and 42? 6. 2 goes into both, 3 goes into both, but 6 is the biggest, the greatest. So plus 6 parentheses. 6 times 3x is 18x. 6 times 7 is 42. And if this is being done correctly, then those should be the same. And we'd have x squared plus 6. Those are the GCFs out front, times 3x plus 7. This is grouping. The last method, letter D, is probably the hardest one. And it's like the number pairs, except there is a number in front of the x squared. So 3 terms trinomial, x squared, great, but there's a number in front of the x squared. And unfortunately, there's no GCF we can take out of all of them. So we have to do another method. What is this one called? Split middle term. Split the middle term. So what does this one look like? We're not trying to multiply to 4 this time. I know 4 is the last number. If it was just a 1x squared up front, that's what we would try. But in this case, because there's a leading coefficient, you're going to take 3 times 4, which is 12. And can you think of two numbers that multiply to 12 and add to 13? And in this case, we need to multiply to negative 13. So what are we going to do with both of those numbers? So do they still multiply to positive 12? Yes. Do they now add to negative 13? Yes, and we needed that. So we're going to take this and split the middle term with these terms. And in other words, that green is going to become 3x squared minus 1x minus 12x. This is where I'm using those numbers at. Together, this makes the negative 13x that was originally there plus 4. So these two greens are equivalent to each other, but that middle term has been split up using that magic pair. And once you have it in 4 terms, then go back and group it. I'll go ahead and pause for a second. If you get to this green that I have down here, can you finish that one using the grouping method? We split the middle term, now group it to finish the factoring. First GCF is x, parentheses, 3x minus 1. Second one is a bit more difficult. What goes into both of those? 4. But we're not going to take out a 4. We're going to take out a negative 4, which makes the inside become 3x minus 1, which is identical to the other one. That has to happen. If we only took out a positive 4, then the inside wouldn't have been the same. So then, like the grouping before, we have x minus 4, those GCFs, times the matching 3x minus 1. If we multiply this out, it would get us back to the original, but we want that factored form because this is linear, and then eventually we'll be solving from those. So methods of factoring: difference of squares, number pairs, grouping, split middle term, and this last one, it looks kind of like the difference of squares, but why is this not difference of squares? It's okay. If like letters, we can make it work. It's the minus that's the problem. It's got to be difference of squares. This is sum of two squares. This one does not factor. It's an example of Logan Paul's new beverage. It is prime. Or is it Jake Paul? It's Logan. Do you know how much caffeine is in those? 200 milligrams. You know how much is in a regular cup of coffee? Like 100. The Prime energy drink, 200 milligrams of caffeine in those things. Crazy amount. So this is prime. What does prime mean to us? Prime means it won't factor. There's no way to factor it. It won't factor. We run into some other ones, but this is an example of one that will not factor because it's sum. There's no way to make it work. If I tried a plus b times a minus b, it wouldn't multiply to that. If I tried a plus b times a plus b, it wouldn't multiply back to that. This is an example of something that is prime. It will not factor. Let's get into some examples kind of jumbled up now. Number 1, x squared minus 4x minus 12. So you can just write down number 1. Here's the example. And we're also going to write down the method that we use. What is this one called then? It wasn't? It wasn't in my box. I don't know.
She said she thinks you didn't look in your box, and I was like, well, we'll never get at it.
I did. I James. Yeah.
I would not take that research, but it's down.
All right, so this is number pairs, and that was letter B from up above, number pairs. So what pair of numbers multiply to negative 12 and add to negative 4? Multiply to negative 12, add to negative 4. 6 and 2 is close. -6, +2. Now do they multiply to the -12? Yes. Do they add to the -4? Yes. And the nice thing about number pairs is that you can go straight for the answer then. X - 6, X + 2. Sometimes it's called the easy method. Not that it's easy, but it's easier because once you have the pairs, you just go for it. Whereas number 2 is a little bit different. So copy down number 2. Why is this one not number pairs? Because of this 2. What is it? Split middle term. I think that was letter C or letter D for split middle term. To do split middle term, what numbers get multiplied first? 36 and 2. So 2 times 36, I'll help you out. That is 72. There was no 72 in the original problem, but I'm still going to write a 72 out here. 2 times 36 is 72. What multiplies to 72 and adds up to 17? Multiply to this, add to that middle number. 1 and 72, no. 2, 36, no. 3 times 24, no. 4 times 18, still way too big. 6 goes into it 12 times, still too big. 6 plus 12 is 18, not 17. So this is pretty close. 7 doesn't work. 8 times 9 is 72. 8 plus 9 is 17. So that's the pair that we want. So I'm just rifling through this, starting with the number 1, going up until I find a magic pair. Now, can you split that middle term using the 8 and the 9? I'll go ahead and pause here for a moment. Because 8 and 9 are the pair, take the 17x, call it 8x and 9x. These two terms are splitting that 17x in the middle. Group, group, group. 2x parentheses x plus 4. You take a 2x out of both of them. Then the back half, what goes into both 9x and 36? 9. So plus 9 parentheses x plus 4. Good news, those x plus 4s are exactly the same. We needed that to happen. So in the final factored form, we have x plus 4, the common, like what they both had in common, times the GCFs of 2x plus 9, and there it is factored. So we had number pairs. Now we have split middle term. Here's number 3. X squared plus 16. What do you notice about this one? Only 2 terms, not 3. They're separated by a plus sign. Look back on the chart we had above. Which one of these applies to this x squared plus 16? Isn't it this bottom one? Right? It says x squared plus 16. If it was minus 16, it would have been a difference of squares, letter A. But this looks like that kind of problem. A perfect square plus a perfect square. So it's method E. This one is prime. It will not factor. Which is different than saying, I don't know. It's prime. Okay, 4, 5, and 6. I'm going to pause, give you a chance to see if you can do some of these. Maybe you can get all 3. Great. See what ones you can do. So we had some time to work on those. The first method is going to be the number pairs. I think that was letter B from up above. What pair of numbers multiply to -6, add to -1? 3 and 2 are close. More specifically, it's -3 and 2. They multiply to -6. They add to -1. So with number pairs, I can go directly to my answer. It's going to be x minus the 3 and x plus the 2. Why is it this method? Because there's 3 terms. Quadratic x squared, there's nothing in front of this one. It's like a 1 right there. Number 5 is grouping. I think that was letter C. Group, 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 group. The first GCF is x squared. The second GCF is 3. The number or the terms on the inside are the same. So we're going to have x minus 5 times x squared plus 3. Number 6, only 2 terms. Of all the factoring that we've done, only one of them has 2 terms. That's letter A, difference of squares. And these are both perfect squares separated by minus sign. That's the difference part. The square root of 9x squared is 3x. The square root of 64 is 8. So we're going to have a 3x minus 8 and a 3x plus 8. So factoring. 4 kinds of factoring, and again, the one that wasn't identified, this one is prime. The reason why we factor is because we solve. So this is the same box from the other page. You don't need to bring that down again. But now we're looking to solve these. So copy down number 7. And you know what, I'll tell you, let's just go and get rid of those y's. You don't really need those. That just complicates the problem a little bit. So step like this. This isn't a great problem. Because if I get rid of those things, let's do this. No, I don't want to do that either. It's kind of a bad problem. Because now, if you look at what we have left, 2x minus 2x gone, subtract 10, you get 0 equals 0. So I guess maybe it's a good one to talk about. What happens when you get 0 equals 0? Close. Infinitely many solutions. Yeah. So this didn't even turn into a factoring with that little edit that I made to it. But this is something that we saw in some of those other linear problems. When everything cancels out and you get a true equation, it's infinite solutions. If we had like 5 equals 0, then it would have been no solution. So kind of a weird one to lead off with factoring because we didn't have to factor that one at all. All right, so number 8. Number 8's a better one. Go ahead and copy it down. Goal here is to solve it. To solve it, we're going to factor it first. Now, in all the problems that are requiring factoring to solve, what do we have to get one side equal to? 0. This is the biggest term, so let's get everything to the left. There's already 36x squared on the left. How do we move the negative 12x? Add it. How do we move the negative 1? Add it. So now it's equal to 0. There's 3 terms, 1, 2, 3. Quadratic x squared, but now we have a number in front of the x squared, right? It's not number pair. What do we call this one? Split middle term. I believe that was letter D from the other side. Split middle term. When you do split middle term, multiply the A value, the first one, times the C value, the last number. 36 times 1 is 36. That's what we want to multiply to. So we're looking for 2 numbers that multiply to this 36, but add up to how much? 12, the middle one. Can you think of 2 numbers that multiply to 36 and add to 12? So split this middle term with 6 and 6. Instead of 12x, it's going to be a 6x and 6x. Right there it is split. 36x squared plus 1 equals 0. Then group to factor that. 4 terms, you go into grouping. What is the GCF for the 36x squared plus 6x? What goes into both of those? 6x. Then we'd have 6x plus 1. The back group is a little different. What goes into both of those? 1. Good answer. So it's not nothing. Usually 1 is a trivial answer. Like, of course, 1 goes into everything. But we do need to take out a 1. So 1, it stays the same as 6x plus 1. Factor it a little bit more. 6x plus 1 because that's the same. 6x plus 1 because those are the coefficients. It's actually a perfect square. But the goal here was to solve, so we don't just stop here. When you have it equal to 0, we're looking to solve it. At the end of the problem, I should say x equals this. Well, what makes 6x plus 1? What makes this equal to 0? Set it equal to 0 and figure it out. It's now a nice linear equation. So to solve this blue one, what would you do to both sides first? Minus the 1. So minus 1, minus 1. 6x equals minus 1. Then what would you do to both sides? Divide by 6, divide by 6. So x equals negative 1 over 6. And then because the second factor is exactly the same, what solution do you think you would get out of that if you solved it? Same thing. So you can write it twice. You don't have to. It's just x is negative 1/6. When there's an equal sign, get it equal to 0, factor, and then solve it. All right, last problem. X squared plus 4x minus 45 equals 0. Great, it's already equal to 0. I love that. What kind of method do we call this one? Number pairs. I think there's letter B from the previous page. Number pairs. It's number pairs because it's just a 1x squared. Great, that makes things a lot simpler for me. The magic number is just the negative 45. What numbers multiply to negative 45 and add to 4? 9 and 5? What do you have to do with them to get a negative 45? One of them's got to be a negative, so we have to add to a positive 4. So which one of these will be our negative? 5. Because now they multiply to the negative 45. They add to positive 4. I like this method because I can go straight to the factoring. X minus 5, x plus 9 equals 0. There it is, factored. But again, in the equals 0, we're looking to solve. So set this x minus 5 equals 0. I'd say each part equal to 0. Also set the x plus 9 equal to 0. So what answer do you get from the first one? Positive 5. The other one, negative 9. And there are our solutions. So factoring and then factoring to solve.